Okay, thanks, Simon. Next case is about anaerobic digestion, still in Italy, this time with another wastewater utility, still in the north region of Italy, with BrianzAcque. So in this case, BrianzAcque wanted to upgrade or replace the current sludge mixing system in their anaerobic digester, because it was outdated and an old fashioned system, let's say. And the goal here was to improve the sludge mixing for optimal biogas production. So the current design, system 1, their current sludge mixing system, it was made of 4 sludge recirculation pipe that you see on the top of the digester, where the sludge is being recycled from the bottom back to the top of the digester, and 6 gas lances for the recycle of the biogas, to enhance the mixing in the bottom part as well. So there we first started with the current design, system 1, and we tested also other design or mixing technologies, and here we are presenting the new design, the new mixing system they decided to go for, and this new design, system 2, in this case they replaced this sludge recirculation pipe and the gas lines with 4 sludge recirculation pipe at the site, recycling sludge at different heights and in different angles, different orientations, with nozzles injection. So there we started with the more conventional CFD hydrodynamic study, where we could analyze and understand the flow pattern in the digester. Here you can see now an animation of a plane from the bottom of the digester moving up to the top of the digester, and the velocity magnitude are being shown here. So you can see that with system 1, so with the current system, very low velocity, very low mixing of the sludge occurs at the bottom. So you see that velocities are almost 0, so in blue. And while with the system 2, so with the new system for the sludge mixing, velocities are much higher thanks to this nozzle, which can really increase the movement, the mixing of the sludge already at the bottom. And as the plane go high, we can see that the velocities decreases in system 2, and again they go up in the top part, where the sludge is being recycled also from the top. While in system 1 we can see that there is a bit more turbulence at the top due to the presence of these gas lamps, which is recycling the biogas, leading to more turbulence, but only in the top region. So next to this conventional CFD hydrodynamic study, what we also did, we included the behavior of the solids, so the suspended solids concentration, to have an evaluation of the long-term operation of these two systems. And in system 1, you can see that in the long term, a thick layer of highly concentrated solids is being formed at the bottom due to the very bad mixing in the bottom. And this is what also BrianzAcque could suspect it was happening in their digester. And there we proved that their feeling was actually correct, and there was a thick sludge layer in the bottom of their digester. In system 2, this can be minimized thanks to this better and enhanced mixing due to the nozzles injection. And finally, we could quantify the improvement by looking at the suspended solid distribution in this bottom part of the digester that is more difficult to mix because of the tendency of the solids to accumulate at the bottom. So in system 1, so the current system, you can see that there is a huge variability of the suspended solid concentration in this bottom layer from very low or low concentration to very high concentration, while in system 2, the orange line, this is much more improved, and you can see the curve is very steep, is almost vertical, which means that the concentration is very uniform. And in this case, the BrianzAcque could really save a lot of time in testing and in deciding which technology they should go for. So having a more efficient design in the end, and also de-risking of the design by having the possibility and the flexibility to test different configuration of solid mixing system. And finally, also a reduction of the cost that normally comes along with more efficient and better designs.